Last video here, number 6, graphing real data. Remember, when you're graphing any real data, you need to make sure that you have a title for your graph. You need to have labels on your axes. You need to choose a scale that fits on your graph. You don't want to draw a graph, have it out here, and have your line look something like this. That would be silly, wasting all this beautiful graph paper. So you want to try and make your graph big enough to fit the entire graph. You want to use proper scales. And of course you want to use some realistic values, some realistic numbers. I'll talk about that in a second here. So here's our real life situation. The cost, C dollars, to rent a hall for a party is given by the formula C is equal to 100 plus 5N, where N is the number of people who plan to attend. The hall can accommodate a maximum of 100 people. Make a table of values. Use the appropriate values for N. So that's what I meant by using realistic values. So we know that we're going to be selling tickets to get into the door for this party. We know the maximum number of tickets we can sell is 100 because the hall can only hold 100. So the biggest number of tickets I want to use is 100. And I want to choose some other points. Now, realistically, I'm not going to choose 1 ticket, 2 tickets, 3 tickets, 4 tickets, and then 100, right? 1 ticket isn't going to tell me a lot of information on the graph that I've got to plot here, especially if I have to go from 0 to 100. So I space that information out a little bit. Okay? Maybe, well, what happens if I sell no tickets to this party? Maybe we'd want to see what happens at 0. And then we want some values in between. I'm going to choose, let's say, 20, 40. We'll skip 60 and we'll do 80. 20, 40, 80, 100. So 0, 20, 40, 80, 100. And I take that and I substitute that information into this equation. And I do those steps that I did before. So 100 plus 5N. C is equal to 100 plus 5N. Well, if N is 0, then this is 100 plus 5 times 0, which is equal to 100. I do it again. C is equal to 100 plus 5N. This time N is 20. 100 plus 5 times 20, which is 100 plus 100, which is 200. Excuse me. So you repeatedly do those calculations. C is equal to 100 plus 5 times 40, which is 5 times 40 is 200, so this is 300. C is equal to 100. Now I'm skipping a step here just to make it a little bit quicker. 5 times 80. Well, 5 times 80 is 400 plus 100 is 500. And then our last one, C is equal to 100 plus 5 times 100 is 600. So there's the information that I need to graph. So then I plot that information on my graph. I come up with a title. The title is rental hall cost. Something like that. Across my independent axis, axis is the number of tickets. We called it N, and I need to go from 0 to 100 and something. Let's say this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Over here is my cost. That was in dollars. I need to go from 0 to 600, 100, 200, 300, 400, 500, 600. So there's my grid. And then I plot those points. 0 and 100. If no tickets are sold, it's still going to cost me $100 for the hall rental. 20 and 200, 40 and 300, We skipped 60, we went to 80 and, what was it, 500? And then we went 100 and 600, something like that. And then, now at this point, we would have to actually decide whether or not we were going to draw a line through this data or have individual points. Now, in order to determine that, you have to decide, well, is my data discrete? Are they solid things that can't be split up? Technically, tickets can't be split. You can't sell half a ticket. So somewhere along the line, I would say, well, I can't have a half a ticket, so I really shouldn't be drawing a line. The problem is that our scale is so small here that I actually wouldn't be able to represent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it'd be really tough. I'd have a whole bunch of points in here and that would look a little silly. So for simplicity, sometimes I would say, well, in this case, because our scale is small and it's difficult to set so many values in between there, that I actually could just draw a line through this data and call it a day. But really, in this case, if I had a big enough scale, if my numbers, if I could blow this up, if I could blow this up huge and see lots of detail, then I would actually just see dots that go, dots that form my line like this. All right, so just so you are still aware of that, discrete and non-discrete data it's called. So there's my grid, there's my graph. Question C, suppose $450 is available for party costs. How many people can attend? Using the graph, I say, well, if I can only spend $450, $450 is right here. I follow that across my graph, it hits here, and I follow it down to see how many tickets I would have to sell. I would have to sell 70 tickets. 70 people would have to attend. Using the equation, I can say, well, if the cost is 100 plus 5 times the number of people that attend, or 5n, and I know my cost is $450, well, then I can work this equation backwards to find n. Subtract 100, subtract 100, that gives me 350 is equal to 5n. Divide by 5, divide by 5. That means that n is equal to 70. I still get to the same place. Suppose the hall could hold 115 people. How much would it cost? Well, 115 people, well, there's 100. This would be 110. 115 would be in here somewhere. I would follow that up. Let me make this smaller here. I would follow that up where it hits my graph. Follow it across. It would be somewhere in here. Well, this is 600. This is 700. This would be 650. Probably about 675 people. 675 approximately. 675, or sorry, not people. It would cost $675 for 115 people. I can use my equation. C is equal to 100 plus 5n. Well, if now I know I'm selling 115 tickets, then I could very simply calculate that. And in actuality, it is $675. Now, there's a difference between this type of question and this type of question. Not necessarily just because you're calculating for one variable for the other. What it is that when we are asking questions or information about something that is inside the data that we have graphed already, we have a graph that's this big right here. That's information that we know, we've calculated, we've plotted. If I'm asking information within that set of data, that's called interpolation. Interpolation. Interpret what's going on inside that graph. If I ask information or data about something that's outside what I've graphed and I have to extend my graph further, well, that's adding extra to the graph. This, whoops, I don't want to erase that. This then, whoops, let's go down here. This would be extrapolation. When I'm looking at data outside the normal parts of the graph I've already created. So inside is interpolation, outside is extrapolation. Just a couple of new terms that you might come across at some point. Okay. Questions for 6.4 noted at the bottom of the page. Remember, the only way that you can get better at any of this is to practice, practice, practice.